Welcome back to the London Futurists podcast. Our guest today is Noel Hurley. Noel is a highly experienced technology strategist with a long career at the cutting edge of computing. He spent 2 decade-long stints at ARM, the semiconductor company whose processor designs power hundreds of billions of devices worldwide. Today, he's a co-founder of Literal Labs, where he's developing Tsetlin Machines. Named after Michael Tsetlin, a Soviet mathematician, these are a kind of machine learning model that are energy efficient, flexible, and surprisingly effective at solving complex problems without the opacity or computational overhead of large neural networks. AI has long had 2 main camps or tribes. One camp works with neural networks, including large language models. Neural networks are brilliant at pattern matching and can be compared to human instinct or fast thinking, to use Daniel Kahneman's terminology. Neural nets have been dominant since the first big bang in AI in 2012, when Geoff Hinton and others demonstrated the foundations for deep learning. For decades before the 2012 Big Bang, the predominant form of AI was symbolic AI, also known as good old-fashioned AI. This can be compared to logical reasoning or slow learning in Kahneman's terminology. Tsetlin machines have characteristics of both neural networks and symbolic AI. They are rule-based learning systems built from simple automata, not from neurons or weights. But their learning mechanism is statistical and adaptive, more like machine learning than traditional symbolic AI. Noel, welcome to the London Futurist podcast.
Thank you very much. Great to be here.
Thanks so much for joining us, Noel.
Noel, I gave a very brief introduction to Tsetlin machines, and I imagine I probably pronounced them wrong. Please give us a better and fuller explanation.
Well, firstly, you did pronounce it correctly, so they are indeed called Tsetlin machines after Michael Tsetlin. Your analysis is quite correct in the sense that the fundamental difference between where we're taking AI versus the neural network approach is by taking a logic-based approach, an automata-style approach to AI, but in the process, also taking on board all of the learnings that we've seen over the last couple of decades, whether that be applied to neural networks or whether that be applied to any other type of machine learning, including things like decision trees and those types of technologies as well on the machine learning side. It is as a result of 5 years of collaborative research between Newcastle University, one of our founding professors, Alex Yakovlev, who himself studied under Michael Tsetlin in St. Petersburg in the days of the USSR. He was doing work on automata and met up with Ole Christopher Granmauer at the Centre for AI Research in Norway. And they started a 5-year collaboration looking at how do we apply some of these logic-based approaches to modern AI problems. And my background at ARM, I'd come at this from the perspective of seeing through the years the complexities associated with a number of different algorithmic approaches to AI and algorithmic approaches to anything, actually, and what effect that has on microprocessors, what that effect that has on GPUs. And when I came across this technology and Alex and Ole Christopher, what really got me excited is this approach that allows us to, instead of frankly, multiplying numbers together, which is what is at the heart of a large neural network, is a large array of multiplication. Instead of us deploying huge arrays of multipliers, we could take a logic-based approach. And at the end of the day, when you multiply 2 numbers together, that circuit on a chip is orders of magnitude bigger. It burns orders of magnitude more energy. And so if we can move those functions into more logical functions, we will end up with models that are faster, models that are far lower energy. And the beauty of logic as well is it's very explainable. And that is a nascent advantage that I think will become more important as we go forward.
By logic, you mean just like adding 2 bits together or checking that both of them are on, and if they're not both on, then turning the output off, that kind of thing?
Yes. By logic, I'm talking about classic ANDing functions, OR functions, those types of classic logic circuits that, as I say, are orders of magnitude simpler than trying to multiply two numbers together. Multiplication, when you move it into the digital space, when you're trying to design a circuit to multiply two numbers together, is an incredibly difficult thing to do. We grow up with it as analog human beings, as it were. We learn our times tables. When you try and build a circuit that does that, it's a far more complex circuit than comparing two numbers and saying, are they the same or are they not the same?
Some of the claims that are made for Tsetlin machines are also made by proponents of neuromorphic computing, wanting to move away from these large matrix multiplication in order to be much more energy efficient, much faster and more flexible. Is there any relationship between the two approaches, Tsetlin and neuromorphics, or are they completely unrelated?
I think it's fair to say they're unrelated. They are two, should we say, neighboring approaches. I wouldn't go so far as to say competitive. They're like tools in a toolbox, and they have particular characteristics with their own strengths and weaknesses. So I'd have them as neighbors in terms of technology.
Yeah.
Do you envision that in the future, Tsetlin machine-based approaches will replace nearly everything that today's AI chips are being used for?
I think neural networks are, as you said earlier on, very good at pattern matching. And in particular, in areas where you've got real subtlety in identification of, say, objects or patterns. One of the challenges with a logic-based approach is that at some point in the pipeline, you have to decide whether you effectively go to a naught or a one. Where we spend our time and effort is there's a certain degree of pre-processing data that's required to ensure that you're not throwing away the important information when you make that switch into naught or one. Typically, you have to work a little bit harder at getting the accuracy level up, and we've seen that. So where we spend our engineering effort is on certainly pre-processing of the data. We then use a lot of the classic learning training techniques within our logic-based approaches. But we have to spend a little bit more time getting the accuracy level up. But when we get to that point where we've got good accuracy, that's where we're seeing published MLPerf numbers showing with 54 times faster, 52 times less energy. One of the questions I get asked regularly is, where's the strengths, but where's the weaknesses? And I'd say we have to spend a little bit more time engineering our solution versus a total black box. But it's worth it. Actually, in most cases, for most customers, they know what they're looking to achieve. They have a specific area that they're working in, and they know what they're looking to try and achieve. So you never have a completely blank, wide stream of data coming at you. You know what the data is. You know the kinds of patterns that you're looking to recognize, and therefore you can start to hone your solution in on that.
So what will be some of the first applications? If it's not going to be replacing ChatGPT 5, is it going to be doing better analysis of medical scans? Is it going to be figuring out what disease somebody might have from a bunch of different indications, or something else instead?
Right now, as a business, we're focusing in on the edge AI market space, and in particular, industrial edge. And that's because when you get to the edge of the network, the devices at the edge of the network have compute constraints, they have energy constraints, and they have cost constraints. So there's a highly constrained market application space. As a uber efficient technology, then we play very well into that space. And so the kinds of markets and applications that we are currently working on are time series data that is coming off sensors, and you are looking for anomalies. You are doing classification, pattern matching of time series data at the edge. That's one area. The other area, which is super interesting, is in the decision intelligence space. Effectively taking tabular data out of databases and forecasting, and again, pattern matching, anomaly detection, all of those types of applications. So we're focused very much on industrial. We're focused very much on how do we make our industrial customers improve their productivity, give them greater insight into what's happening, whether that be in a manufacturing process, whether that be in a utility network, machine health, all of those types of areas. That's where we are today. That is not necessarily where we will end up, because as you talked about, we look at the whole gamut of AI all the way up to large LLMs and transformer technology. I think going forward, as we mature our business, there is a large part to play for logic-based approaches. I quite like the think fast, think slow analogy at the top of this podcast. I look at it as you've got the core of the brain, which is taking all of this visual information that comes in, but then you've got the frontal lobes, which is all about what if scenario planning. What is going to be our strategy in a particular scenario? Actually, logic-based approaches play very well into that space. How you develop strategies, how you plan going forward. We can take that brain analogy one step further and just say, I think logic-based approaches are going to sit alongside classic neural network approaches and be another tool in the toolbox as we start to build towards ever-increasing and more sophisticated AI.
Well, it's the way humans work that we use both logic and instinct, both pattern matching and reasoning, both fast and slow, so it makes sense that machines would as well. Do you have systems in operation at the moment with clients? Have you got systems at work in factories improving productivity at the moment, or is it still a research activity?
We spun out of the university at the back end of 2023. We're at that proof of concept stage. We raised 4.6 million pre-seed. We closed out that round at the middle of this year. We've got a whole bunch of very exciting proof of concepts. They're confidential at this stage and are building out our product. And let me just say, we've talked a lot about the technology, about logic-based approaches. Actually, as a company, the product that we're bringing to market is a tool chain that's going to allow our customers to take their data and train logic-based models for themselves. So they'll be able to create custom models using their data sets. And I'm using the rather woolly, a reasonably competent software engineer should be capable. You don't need to be an AI expert. So as part of our tools, obviously, we're using a lot of AI and learning techniques in the training, selection, pruning, and optimization of models. A lot of that is an automated process as well.
I was thinking that when you said your product's a tool chain to allow clients to train logic-based models themselves, that was going to restrict you to pretty savvy AI organizations. But you think you can go further down the pyramid and work with reasonably competent software engineers?
Yeah, so let me give you some ideas. One area in which we're working will be delivering in the order of about 1,000 models to a customer as a package. To get to that point, we're training 60 to 70,000 models a day. This is all part of that tool chain. Effectively, as a customer, you're giving the inputs. What are you looking for? What are the bounds? And that then becomes the input to spinning up a large training pipeline that then searches across that space, trains models in an automated fashion, and then prunes and selects the candidates that match the criteria.
That's a lot of models. Would you describe these models as agentic, as in, can they affect the real world and have a degree of autonomy?
They could indeed be agentic. If you think about agentic AI as self-contained models, personally, I'm watching that space very closely, and there are certain parallels to some of my experience in semiconductor space. I look at the agentic AI market, and actually, for me, the critical thing that I'm watching for is who's going to be delivering the unified interface that allows AI models to cross-communicate with each other.
Is that not MCP from Anthropic?
Well, we'll see.
Yeah, it's early days.
It's early days, so I think that's going to be the critical industry step, should we say.
I should declare an interest at this point. I'm a co-founder and David's an advisor of a company called Contium, which is launching a verification service for AI agents on the basis that there are going to be billions of these things running around, doing deals, spending our money. We really need to know that they do what they're supposed to do and not do anything else. Conscience verification service will make sure that that is the case.
But you said that in some ways your devices were less black box than some other AIs, more understandable perhaps. Can you say more about that?
Yeah, the models that we produce, you can think of them as we bring in data, you start the process with a set of logic steps. You can think of them as clauses. They're like sentences. They are basically if-then statements. So if this, then that. And then a Tsetlin machine is actually a voting algorithm. When you're going through the training process, you are voting to include, exclude, or ignore those if-then statements. I'm oversimplifying, but you get the idea. When you then deploy the model effectively is a whole bunch of clauses with those voting parameters, include, exclude, or ignore. That means that you can go back and validate that model. You can trace through that logic, and that's one of the beauties of logic. It is traceable, it is stable, and that's how you gain this explainability element. I'm not saying they're super easy to explain.
And when you say it's traceable, I'm taking it there's not billions of layers stuck on top of each other. You might be able to make sense of 2 or 3 layers of logic, but when there are billions of layers, it becomes impenetrable and opaque and mysterious again.
Indeed, any complex model is going to be super complex to explain. It doesn't necessarily simplify. However, again, coming from a semiconductor background, and if you think about semiconductor chips, they are huge arrays of logic, fairly random logic, made up of many billions of gates. And we do routinely verify those designs. So the techniques and tools and concepts are available today in a parallel market, i.e. the semiconductor chip market. And so I'm confident that we'll get to the stage where, yes, you can provide a degree of explainability. But I'm not saying if you try and build a model of the UK economy, it's not going to be a really complicated model. I mean, you can't get around complexity in that way.
Yeah. So this is the London Futurists podcast, and we do like to talk about the future. Noel, I wonder where you stand on the debates about the longer-term impact of AI. Not so long ago, talking about superintelligence was a fringe pursuit, and now we have the heads of big AI, Google DeepMind, OpenAI, and Anthropic, all saying that it's entirely possible we'll have superintelligence by 2030. Do you spend much time thinking about this, or do you think it's science fiction?
I don't think it's necessarily science fiction. Look, AI is going to continue to progress. We will have new inventions, new IP, new techniques, new tools that are going to come out. They're going to continue on an innovation treadmill. That, I think, is certain. I do worry to a certain extent about what the role of the human is as we move forward. I think there are societal issues that we do need to think about going forward. And I must say, actually, on our side, we're focusing our efforts on improving productivity of the customers that we work with rather than necessarily cutting cost. I think it is a more enjoyable area to be working on. I'm more focused on growth. How do we improve productivity? How do we grow? Rather than the cynical side, which is, oh, well, we'll do this and then we can fire a bunch of people. I don't see how that helps us moving forward. It's destructive. And actually, at the end of the day, there is a danger that if you take that disruption to its extreme, you're actually value destructive, not value creative.
Yeah. There's a lot to be said for the argument that if you use AI to cut costs, and that simply means that you reduce headcount, then you lose all your talent. You're dismissing your talent. A better model is to have your people automate their existing jobs, call them a hero and reward them and get them to go on and automate something else and keep making the process more efficient, but keep the talent on board and make them more and more heroic as they do that. I suspect at times it's going to be really, really hard to do that, and it's going to be hard to resist the temptation to simply reduce headcount. I mean, there's 2 things a business can do to improve their performance. One is cut costs and the other is increase revenue. And cutting costs is at least half of that.
I also think there's got to be more to AI than increasing the number of blandly written emails.
Let's hope so. Although humans can write pretty bad emails too, so there's a job to be done in increasing the quality level of that. We don't know how far automation can go before there is simply no more headroom for humans to remain involved in the process. Automation's been around for a very long time. Previously, when a job gets automated, when an industry gets automated, the people doing those jobs went on to get other jobs. If that wasn't true, we wouldn't be nearly at full employment, which we are. But of course, we're seeing with AI a different kind of automation. We're seeing cognitive automation. We don't know how long that can go on before the machines do take pretty much all the human jobs. And it's obviously something that ought to preoccupy us more, because if we do get to a world of full automation, a world in which lots of new jobs are being created, but they're all being taken by machines instead of humans, we need a different type of economy. Hopefully, capitalism can survive in some form, because none of the alternatives to capitalism have worked out very well so far. But it's not easy to see how the economy works, where humans are getting what they need to have a good standard of living, not through jobs, through some other mechanism, probably through redistribution. It's a tricky subject. The economists of the world should be spending a lot more time thinking about it than they are at the moment.
I agree. But when I put my optimist hat on, history tells us that human beings are incredibly adaptable. And also, it was about 10 years ago when I was at ARM, I was doing a couple of presentations around low power in the early days of AI and machine learning. And some of this is slightly old now, but at the time I was looking at the energy consumption of human cognition versus machine. And a couple of interesting things came out of that. One, if you look at energy per gram, there's twice as much energy per gram in broccoli as there is in a lithium-ion battery. When you start to add things like butter and chocolate, wow, orders of magnitude, more energy per gram. But on a more pointed note, when AlphaGo was out and it had just beaten the world champion at the time, and when you work it out, a game of Go takes about 4 hours to play. A human will consume the calorific equivalent of 3/4 of a Big Mac during that 4-hour period of playing Go. AlphaGo consumed in the order of 3,000 Big Macs to play the same game. And so biology is incredibly energy efficient. And in a world where energy is becoming increasingly a challenge, maybe that's the brake on an endless march towards complete automation of everything.
Well, maybe it is, or maybe it simply means that your approach, the Tsetlin machines, and also the neuromorphic approach, which is also about dramatic improvements in energy efficiency, maybe that gets combined with large language models and other approaches, and the whole thing gets much more efficient and gets much closer to the human level of efficiency.
Yeah, from 3/4 of a burger to 3,000 burgers, it's got a long way to go.
Yeah. So you've been in the AI space and adjacent spaces for a long time. If you think back to yourself 20 or 30 years ago, what do you think would surprise that younger version of you most about the state of computing today?
I think the scale of compute, what we're seeing right now, when you look at trends going back, say, 20 years when cloud computing was starting, actually what we're seeing now is we're reaping the rewards of just the amount of compute you can spin up and how accessible that amount of compute is. That is actually what's allowing us, in our business, for example, allowing us to build pipelines that can train 60, 70,000 models a day. As a result, what used to be a highly crafted process, you can now throw compute at the problem, I say in inverted commas. I'm going to set something up and I'm just going to let the computers run with it. In terms of design and that step in design mentality, we're starting to really see the rewards of that. And that's also how, from the original neural networks and highly crafted, now we've got many billions of tokens being processed to train these models. I think that's been one of the biggest steps over the last couple of decades that we're really starting to see the impact of now.
Let me ask about a different kind of surprise from 20 or 30 years ago, when both you and I think, were close to the heart of what seemed a very promising British technological wave with ARM. I was at Cyan and then at Symbian, and we really thought that plucky Britain could be world leading with many of the technologies. But it seems now that we've been overtaken by Silicon Valley and a lot more besides. Is that a disappointment to you? Do you think that there is a renaissance possibly ahead for British high technology?
When I joined ARM, it was about 40-something people, and Robin Saxby was the original CEO. And even from that point, there was a very clear vision that we were a worldwide company. Yes, we were based in Cambridge, but we were a worldwide company. We then became very successful. We were super competitive. I can't remember how many microprocessor architectures there were in the mid-late 90s, but it ran into the tens. And when you look today, is basically ARM, RISC-V, and x86. And so we were very successful. If you become a very successful international worldwide company, it's no great surprise that actually you move around. We opened up offices everywhere. So I'm less concerned, and certainly don't take the view that, yes, it was a great British success, and therefore it will always be under 100% British ownership. That's never going to be the case. I am concerned, though, that we've not been able to replicate it, because I do think there's the talent. I think there's a little bit of self-sabotage that goes on, not just in the UK, but I think it's also true in Europe as well. There's expectation that as soon as you get to a certain size, you must move to the US. I think that is not always the case. I certainly push back against the UK can't market businesses. We have a different style. We're not as out there as, say, the US in terms of we have a slightly more dour approach. But actually, there are markets where that plays well. It plays particularly well into many of the Asian markets, and ARM saw much of its success with Asian customers early on. And that's because actually they value that considered and, shall we say, more, I don't want to say dour, but culturally it played well into that market. And so I would like to see us build more international powerhouses. I believe we can do it. I don't think there's anything intrinsic in the UK. We have some structural issues in terms of access to capital at that growth phase. Startup capital, there's a lot of startup capital around. Unfortunately, with many European and UK, they are more risk averse. So that is a challenge at the very early stages. I think the real problem, though, is when you're trying to do that B to C round or A to B to C rounds, getting that access to large amounts of capital to do that expansion. That is a structural issue that by the time we get to that stage, I hope somebody else has fixed.
Yeah, we have a structural problem throughout Europe that our financial institutions, banks, and particularly insurance companies, the people who have large pools of capital, allocate such a small amount of it to private, non-public businesses. I looked at the numbers recently. The amount that the American institutions allocate to private equity of various kinds isn't actually all that big. I can't remember whether it's 0.19%, something like that. But that's still 20 times the level that UK institutions do, and I'm sure the European ones are lower. So that capital issue is enormous, and I know that Labour is trying to address that, and maybe they will. Good luck to them. As you say, there's a sort of a cultural worry, there's a self-sabotaging goes on. But it does always seem to me that the real impediment to Europe developing big tech is the fragmentation of the market. If you start a business in Miami, you can sell its products in Massachusetts the next day. If you start a business in Milan, it is really hard to sell the products in Manchester or even Marseille the next day. If the European single market could be finalized, be completed, big project, I think that would do a great deal. And I'd be really interested in your thoughts on this, because one of the things that you hear, particularly from Americans, is that the reason why Europe doesn't have any big tech is regulation, that Europe is over-regulated. This seems to me to be just not true. The US has tons of regulation. It's not short of regulation, and it varies from state to state. The EU may be more forward thinking about AI regulation, and perhaps it's over the top. I don't know. I'm not convinced it is. But it doesn't seem to me that regulation is the reason why Europe doesn't have big tech companies. Do you have any thoughts on that?
Yeah, I tend to agree with you. In Europe, we're currently dealing with AI regulation right now. It's in its early stages, so there are various holes and so on that you can pick in it. But there is a process you go through. It will mature. It will get better. The EU is well known for pushing things out. It does actually listen. It'll push out regulation if it's going to damage business within the EU. I think the UK is the same. So I don't see regulation as the issue. I do see a fundamental attitude to risk is actually one of the big challenges. American VCs, American companies will take bigger risks. They are more likely to go all in. And so when they hit a winning formula, they maximize the return of it. Whereas I think in the UK, and I think it's true across Europe, it's a far more cautious approach. And that means that when there is a win, more often than not, there's a chance that somebody will copy you and beat you to it because you've been too cautious in your approach. So I see it more as an attitude to risk. But, at the end of the day, how do you change an attitude to risk? Well, that comes down to, human behavior really only changes when there's a crisis. And so I think it's fair to say on the tech front, certainly many in Europe, and I'd include ourselves in that, should be looking at this as a crisis. There is a crisis. Tech is going to be our future. It's going to be a massive economic driver for all countries. You have to be in it and have some leading elements to it to be successful as a nation. So it should be considered a crisis. And that means placing some bets.
I couldn't agree more. Europe has got the message now that it needs to rearm. It needs its own defense capability. And I think absolutely the same applies to AI. AI is going to be an enormous generator of wealth, and it's going to be essential to our security and everything else. It's a mistake to allow our most powerful technology to be a duopoly between America and China. Europe is the obvious other place that can be a third pole, and it really should be.
It, of course, has the challenge of having as many different languages as well. So the go-to-market is, as you mentioned earlier on, more complicated. It's a real melting pot of different cultures, languages, etc., that make it a more fragmented market. But also, you end up with very innovative solutions that come out of that. We can look at companies like Spotify out of the Nordics, who are world leading and have built up that business. So there are lighthouses, beams, whatever out there to follow. And so Europe is not incapable of building international tech businesses.
Yeah.
So my final question, Noel, would be, is there any other advice that you've got from your distinguished career in the semiconductor industries? The things that you've seen successful, or even lessons from your failures that you think should be highlighted again for this challenge, this existential challenge, in a sense, for the future of British and European technology companies?
What I've learned through my period at ARM, the clarity in goal setting is crucial. As I sit here as a CEO of a business, Literal Labs, we set ourselves a clear set of goals that aligned very well with our investment phase that we were in. We've actually instilled that into everyone within the organization. We talk about them at every meeting. Where are we against the 4 goals that we've set ourselves? And that aligns the team going forward. And so as building the business. Now, and I got that from when we first joined ARM, the mantra was, we're going to be the number 1 risk processor in the world. That was the mantra. It was one of those visions that wasn't written on a plaque and put in reception, but actually used as a tool in day-to-day decision-making. Would option A or option B get us closer to being the number 1 worldwide? And that has stuck with me throughout as part of management philosophy. That clarity, creating an aggressive but clear goal that can be used in day-to-day decision-making is crucial.
I think that is a very good way to end. And let's hope that that clarity, that aggressive clarity of goal setting can help Literal become a lighthouse of the great burgeoning of future EU tech businesses. Noel, thank you very much indeed for joining us on the London Futurists podcast.
Thank you very much. It's great talking to you both.
Thanks.